Welcome to Unit 1. It's Chapter 1, Section 5. This is Video 2. So, we are going to go over, let me make sure I've got my black pen. Reflections about the axes. So, you can think of a reflection as like a mirror, of course, like a mirror image, right? So notice you've got two reflections over the axes. So what this does is this one's equals negative y. So this one flips over the x-axis. Notice it's right here. So that means that we took all of our y's from the original equation, and I'll highlight that one. This is the original. So we took all of our y values and we just made them negative, which is what this says. Now for this one, we're going to take all of our x values and we're going to make them negative. So we're going to flippy flop it over the y. And you can see that right here. See how we just kind of flipped it over the y? And it's okay if, it crosses, it's fine. Reflecting a graph horizontally and vertically. So, remember, if we're changing our y's, so if our y's are changing, we're going to flip it over this axis, the x-axis. That's going to be negative f of x. If we flip it over the y-axis, that's f of negative x. What did they refer to? Okay, they referred to y as the vertical reflection. So this one is the vertical, and this one is the horizontal. So for A, if we want to flip it vertically, we're going to have negative s of t. It's going to be negative square root t. If we want to flip something horizontally, this is what we get. Okay, so notice here that these are not real numbers, right? You can't multiply two of the same number together and suddenly get a negative number. So what this says is, that's the square root. So when we flip it over, this is s of t. This is negative s of t. So what this says is that, well, we can't really do this. We would really have to restrict the domain to negative values of t so that we could get positive values. Because the only time you're getting a positive value is when your t is negative. So you would get s of negative t equals negative t. It's t. But, yeah. Sometimes they don't make sense. So we won't be seeing that one probably in this class. So reflecting a tabular function horizontally and vertically. Okay, so if g of x is negative f of x, all you're going to have for g of x are the f of x values, but just negative. But all your x values would stay the same. Now for h of x equals f of negative x, remember we're going to have to build a new table. Okay, so there's 4 of them. There we go. Okay. So remember, when we do something inside like this, we're going to now make these x's the negative x so that we can keep these values since we're only changing it in the x's. And then that means that in order for negative x to equal 2, my x has to equal negative 2. And the same goes for all of these. And we know that we will get the same thing. So these are our values for b. So this is a and this is b. Reflect the graph of f of x equals the absolute value of x minus 1 vertically and horizontally. So let's think about what this is. So we know that, I'll show over here, we know that the absolute value of x looks like this. So what about the absolute value of x minus 1, where that's on the inside? So hold on, let me erase that. So to get a better idea of what's going on, let's start with our x. If you wanted to compare these two. So we'll do -4, -3, -2, -1, 0, 1, 2, 3, 4. Just kind of get a general idea. Make a table. You can also use these values to graph your function. So we know that the absolute value of x is going to give us a positive value. So it makes that negative value positive. Now when we subtract 1, so it will be 5, 4, 3. So we have -1 minus 1 is -2, which gives us just 2. 1. 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. 3. So what we have is when x equals 1, the y of this function is going to equal 0. Right here. And that's when x equals 1. So it's going to look something like this. You could also, if you wanted to just do this, you could see that it moved to the right. Remember, it is opposite of what that sign is in the middle. So if we want to flip it vertically, that's in the y's. So that would just be negative f of x. So that's what we would be getting. So our g of x would now be negative x minus 1. And for those of you that might be curious, that would look like this. Now, if we have f of negative x minus 1, then what will that give us? Shall we make another table, or guess I don't really have you guys to ask, huh? So you know what? I think I'll add something else to, I'll add another row so you guys can see what's going on. It's going to flip across the y. Should flip across the y. So now we have minus x minus 1. And if you're ever unsure about any function, it is always okay to graph it using a table, unless the question specifically states you have to graph it a different way. But this is always okay. Even in higher level mathematics, you're completely within your rights to make like a table. Okay, so if x is -4, then negative 4 is positive 4, minus 1 is 3. Negative 3 put in for negative x, that's positive 3 minus 1 is 2. When x is -2, we get 2 minus 1, which is 1. When x is -1, we get 1 minus 1, which is 0. When x is 0, we get minus 0 minus 1, which is -1, which is just 1. When it's 1, we get minus 1 minus 1, which is minus 2. And it would just proceed in this fashion. So now what does that tell us? Well, that tells us that our y value, which is the function, is equal to 0 when x is now equal to -1. And I'll do a different color. So it would look something like this. Notice how if you treated this y-axis as your center, it is just a mirror image. Let me highlight these so that I guess you guys can probably better understand. There's that. This one. And see how it just flip-flopped? The x went from being 1 to -1. Okay, a common model for learning. This is modeling equations. A common model for learning has an equation similar to this guy, where K is the percentage of mastery that can be achieved after T practice sessions. This is a transformation of the function f of t equals 2t, shown in figure 15. Sketch a graph of kt. Okay, so what we have is, now I'm going to apply a function. Oh, didn't mean to do that. So I've got the original, and then I have my one with transformations applied. Now what does it look like happened? So it looks like we have, if kt is 2t, well, notice the t is now negative, so we're going to have k of -t is equal to 2 of -t. Oh, this is supposed to be f of -t. So now we need this negative in front, right? So we're going to have negative f of -t equals negative 2 negative t. And then we're going to have negative f negative t plus 1 equals negative 2 negative t plus 1. So this is what we're going to have. So the first thing I would say is I'm going to go ahead and deal with that negative t. So this is a reflection over the y. Secondly, I'm going to deal with this reflection over the x, and then I am going to do the vertical shift. And we're going to do that on the graph of this function. Well, reflect. Okay, so the first thing I'm going to do is I'm going to reflect it over the y. So that means that that f of t axis becomes sort of like my mirror. So if I have 1, 2, so my x is 1 and my y is 2, I'm going to have negative 1, 2 right here. Where's another point we can kind of get at? Right here. If my 2 is x and my y is 3, then it's going to be negative 2. So we're just going to reflect everything. So it's 2 away approximately. 1, 2, right there, here. And now notice that that half line, like that, so that allows us to draw f of negative t. Now what is negative f of negative t? Well, now this is reflected over the x-axis. So that means that if our 2, where's a good one? So here, how it's our y is 1. Now our y is going to be negative 1. Notice here how our y is 2. Well, now our y is going to be negative 2. Notice how our y is 3. Now our y is going to be negative 3. 4, negative 4, and so forth and so forth. So now we are going to get something like that. So this is negative f negative t. And now I'm going to have to add 1 to every y. Let me get a color. We'll do blue right here where it says plus 1. That is a vertical shift. Remember, if it's on the outside, it goes with its sign. So it's positive, so it's going to go in the positive direction. So I'm going to move up 1. So that's going to be this. And this is negative f negative t plus 1, which is equal to k of t. Determining even and odd functions. I'm going to go ahead and leave that for the next video. This video has already been like 20 minutes long. So that was what we just went over was Unit 1, Section 5, reflections about the axes. And I will see you guys in the next one.